Hey guys, this is a review for the assessment, or I should say quiz, that will be posted for you guys tomorrow. This is on simplifying square root and simplifying radicals. So you might want to pause at the start, try this on your own, and then just come back and see how do we approach this. Okay, so here is number one. We want to simplify this. Okay, what do we want to do? We want to simplify this. First thing we can do is we can split this and we can write it down as 8. That's outside the square root. And then we have square root of 36. We have square root of 8x to the powers of 8. And then we have square root of y to the powers of 11. Next thing we do is we try to simplify all the square root we see. 8 is still outside. Square root of 36, when we simplify, that will be 6. Now, what's square root of x to the powers of 8? Remember this, when we have square root with an index of 2 and we have even power, we can simplify this and write it as x to the powers of half of this exponent. So 1 half of 8 is positive 4. Or 8 divided by 2 is 4. So this one will simplify to x to the powers of 4. Now to simplify this last term, we need to rewrite this and we need to say this is the same thing as y to the powers of 10 and y to the powers of 1. Y to the powers of 10 and y to the powers of 1 will make it to y to the powers of 11. So let's go ahead and simplify. We will have 8 times it by 6. That's 48. We have this x to the powers of 4. Let's go ahead and write this and split this. This is the same thing as square root of y to the powers of 10 and square root of y to the powers of 1. Now same thing we repeat here. We have an exponent that's greater than even exponent. We're taking square root. So all we can do is we will first write this two term outside the square root. This one we can take this exponent and just divide it by 2. 10 divided by 2 is positive 5. So this one will simplify to y to the powers of 5. And then we're left with this single square root term, which is square root of y to the powers of 1 is same thing as y. And this is all we can do. We cannot simplify any further down. So that's the answer. All right, let's move on to the second example. In this example, we'll try to add these two radicals. Please pause, try it on your own, and then come back, see how do we approach this. All right, so we know that we can add and we can subtract if we have like radicals. All right, that means if we have something like this, square root of 5 and square root of 5, they both have same index of positive 2. They're both square root, and they both have same radicand, which is 5. Radicand is the thing that goes inside the square root. So if we have same index and same radicand, we have like radicals, and we can do that. We can combine them as we combine any other like terms. So in this case, what we see is inside this square root, I have square root of 7x and square root of 63x to the powers of 9. And we see that this is not the same thing, right? They're completely different. So right now, they're not like radicals, so we can just combine them like this. So the first thing we need to do is see if there's any way we can simplify and make them like radicals. So let's go ahead and try to see this. This term right here and this term. We got two terms. They're both separated by the subtraction sign. This term is simplified because 7 is a prime. We can't do anything else with 7. And we have x to the powers of 1. We can't do anything with x to the powers of 1 when we take square root. So let's go ahead and bring this down. So I'll rewrite this negative 8x squared square root of 7x. Next thing we'll do is we will see if there's a way we can simplify this. And we see this same thing as, that's the same thing as 63 is the same thing as 9 times it by 7. 9 times it by 7 is 63. And then we have x to the powers of 9. Now x to the powers of 9, this is how I'm going to rewrite x to the powers of 9 so I can simplify in the next step. I'll say this is the same thing as x to the powers of 8 times x to the powers of 1. This will make our life so much easier in the next step. We'll bring this down, negative 8x squared square root of 7x. We will split this and we'll say this is the same thing as square root of 9 square root of 7 square root of x to the powers of 8 and square root of x to the powers of 1. Alright, let's bring this down again. Negative 8x squared square root of 7x. Square root of 9, we know that's positive 3. Square root of 7 is a prime, so we can't do 7 anything. So we'll write this as square root of 7. We know that square root of 8, square root of x to the powers of 8 will be x to the powers of positive 4. One more time, if we have even exponent and we're taking square root, we can use this shortcut and trick that we can just divide the exponent by 2. And lastly, we have this square root of x. Let's go ahead with the next step. We write this down again. Let's see what we can simplify. We will multiply the thing that's outside the square root, which is 3 and x to the powers of 4. That's going to give me 3 x to the powers of 4. And then we'll multiply these two. They're both square root with the same index. So we'll multiply inside. So we'll say this is the same thing as 7 times it by x. That's 7x. Alright, now we see that this and this, they both have square root and they both have 7x. These are like radicals. If they're like radicals, we'll just combine them. We'll say this is the same thing as square root of 7x. And I'll combine what's left when I pull out square root of 7x, which is negative 8x squared minus 3x to the powers of 4. That's it. Now these are not like, they have one of them x to the powers of 4, the other one is x to the powers of 2. So we'll just leave them as it is, and we'll move to the next example. In this example, we'll multiply these two binomials, and every time we have binomials, we can multiply and we can apply this FOIL. Wrote it down here inside. This is how when you apply FOIL. For f, you multiply the first two terms, which is a and c. For o, you multiply a and d. These are outer terms, and I are the inner terms, which is b and c. And then for l, you multiply the last two terms. So we'll do it right here like the same exact way. So we'll say, here we go. This is A, this is B, this is C, and this is D. Just be careful with the sign. If we have positive, negative, we'll do it when we multiply. So let's do F. First terms, A times it by C. 7 times it by 7. That's 49. Good. And then O, what do we do for O? O is the two outer terms, which is A times it by D. A is 7. D is negative square root of 3. Gotta be careful with the sign. Negative square root of 3. When we multiply this, we'll get negative 7 square root of 3. Alright? And then we have I, which is the inner terms, which is B and C. B is square root of 3. C is 7. When we multiply, we get 7. That's outside. And then we have square root of 3. Lastly, we have L, which is the last two terms, which is B times it by D. And B is square root of 3. D is minus square root of 3. When we multiply, we get minus, which is outside. And inside, we got 3 times it by 3, that's 9. And square root of 9 is 3, and that's negative. So lastly, we put all these four terms. So we'll say 49 minus 7 square root of 3 plus 7 square root of 3 minus 3. So I'm putting all these four terms. Now let's see if there's anything we can combine and simplify. I see that these two are like radicals, and one of them is negative, the other one is positive. This is known as the zero pair, so we can just easily combine these two and they'll give you a 0. When they do, you're left with 49 and minus 3. So let's do 49 minus 3. That's going to give you 46. The answer is, when you simplify, will give you 46. Alright, let's do the last example. So again, if you want to pause, go ahead, please pause. Try it on your own and then come back and see how do we do this. Alright, so this one, we'll kind of approach the same exact way. First thing, we'll simplify what we have for the numerator. This is the numerator, and this is the denominator. So let's go ahead and simplify. We have 80. Now you might say, how am I supposed to simplify 80? You can always start by doing this. Write 80 as 2 times it by 40. We're trying to find the prime factors of 80. And then we know that number 2 is a prime. Can't do anything else with this for now. Can't simplify it or break it down any further, smaller down. 40 we can simplify, say this is the same thing as 2 times it by 20. This is prime. 20 we can break it down as 2 times it by 10. This is prime. 10 we can break it down as 2 times it by 5. These are both primes. So 80, this number 80 is the same thing as 2 times it by 2, 2 times it by 2, times it by 5. Which is pretty much same thing as 2 times it by 2 is 4, 4 times it by 2 is 8, 8 times it by 2 is 16, times it by 5. And we could see that 16 is a perfect square, right? So we can rewrite this and we can say this is the same thing as square root of 16 times square root of 5, and we'll split these other two terms, which is square root of x to the power of 4, and we have square root of y to the power of 3. And then for the denominator, we have square root of 2. I'm writing 10 as 2 times it by 5, and then I have square root of 5, and then I'll have square root of x. Now if we could see this and simplify this, this will be square root of 16 is positive 4. And we see that this square root of 5 and this square root of 5 will cancel out. So we have positive 4. This one, we have x to the power of 4. Again, we're taking square root. So we will just take this exponent and divide it by 2. So this one will simplify to x to the power of 2. And now I'm going to rewrite this. I'm going to rewrite this as this. This is the same thing as y to the power of 2 times y to the power of 1. Alright, and for the denominator we have square root of 2x. Alright, next step, what do? We go ahead and try to break this down, the y square and y, split it out, and we'll try to simplify this. So we'll say this is the same thing as 4x to the power of 2 times square root of 2y squared times square root of y, and this is divided by square root of 2x. Alright, let's go ahead and try to continue with this simplification. We have 4x to the power of 2. This one, again, when we have exponent, even exponent, we take this exponent and just divide it by 2. 2 divided by 2 is 1. So this will simplify down to y to the power of 1. And we have square root of 2y, and everything is divided by square root of 2x. Now the last step is this. We know that now we need to rationalize the denominator, meaning we need to get rid of the square root from the denominator. How do we do it? We will just take this and we'll multiply the top by square root of 2x, and the bottom by square root of 2x. When we do this, this is what we get. On the top, we multiply numerator times it by numerator. We get 4x squared times it by y times it by these two. Now they're both square root, so I'll put them under the same square root. 2 times x times it by y. And then right here, I'll put these two for the denominator. I'll put those two under the same square root. It's going to be square root of 2 times it by 2, that's 4. X times it by x, that's x squared. Here we go. The next step when we simplify will be this. We have 4x squared times it by y, that's outside. Inside the square root we have 2xy. Divided by, when I simplify the denominator, I'll simplify square root of 4 as 2 and square root of x to the power of 2 as x. Now I see if there's anything that can be cancelled out from the top and the bottom. Yes, I can cancel out 2 divided by 4. 4 divided by 2 gives you 2. And then when I divide x to the power of 2 by x, I'm going to get 1 right over here. So your final answer is this. We have 2 x to the power of 1, or just x, times it by y, square root 2xy. So this will simplify to this.